Okay, so the steam tables. The appendices in the back of your book, sometimes I'll call them the steam tables, all right? Steam tables really officially only works for water, but I'm used to referring to them that way. Steam tables, let's look at the water part of it, and we'll see here, they're table A2 through A5. All right, so as we go to our document camera, here's table A2, and note what it says here. This is going to be the properties of saturated water, the liquid vapor temperature table. It's going to give us the specific volume internal energy. Forget about these other two columns right now. They are not eligible to us right now. We have not unlocked them yet. We're only working with these first two. They give us the location of the value for the saturated liquid and what the value is the saturated vapor. Okay, that's what they just give us. They give us to this point 1 and point 2. And they give us what temperature and pressure corresponds to this. And this table, table A2, is called the temperature table because it gives us nice, even temperatures. Now, if we go to table A3, it's the same table. Table A3 is the same table. It's a property of saturated liquid water, but it's called the pressure table. It gives us the saturated liquid, it gives us the saturated vapor, but now instead of giving us nice, even temperatures, it gives us nice, even pressures there. And so that will be helpful to us as we're getting going through there. So that's the first table we're going to deal with. Saturated tables, either at nice temperatures or at nice pressures. Then the next page goes to our superheated water vapor. What happens if we go past the vapor up and heat it more? We're going to have superheated water vapor, and we have a number of those tables. Okay, and then table A5 is going to be compressed liquid water. What happens if we're below that saturation line? Below that saturation line, we're going to use the compressed liquid water tables. Every one of our things that I talked about, propane, ammonia, R134A, R22, have these tables that we can work with in the appendices. We're just going to have to know where they are and how to use them. All right, so I said A4 superheated water, A5 compressed liquid, A2 and A3 to the two-phase liquid vapors. So let's look at this now. I've taken some of these, taken some digital copies of your tables, and let's look at how to find a property. So here we're going to look at properties associated with superheated water vapor at 10 megapascals and 400 degrees Celsius. So we know right now it's superheated water vapor. So we're going to go to table A4, and I would encourage you to pause and go to table A4 yourself and find this actual entry in your table. Okay? And so I'm going to point it out here. Notice in this table that there's temperatures are only on one side of the table. There's not in the second column. You have to refer to the first column to get your temperatures. Okay, so we're going to get the temperature of 400 degrees Celsius, and we're going to read off over here for 10 megapascals or 100 bars. Here is going to be the properties for each one of that state. Here's going to be the properties for that state. So if you want to find the specific volume, that's where it is, the specific internal energy, the specific enthalpy, and the specific entropy. Now, we're not going to deal with these last two terms right away. We're only going to deal with the first two, but I want you to know they're there. I want you to know they're there. Now, here's the thing. A state does not always exactly fall on the table. Here, I have a cat I want you to let's get here. Get out. Here you can go. You don't want to do this lecture. I'm bored with it. They just think I don't have any interest at all, Dr. Wanklin, with this, except for when the cat sits here in my chair, which often does, sits in my chair. The kids call him Professor Kitty Cat. So that's fun. That's a fun bit of knowledge that you don't really want to know either. Okay, so where were we? We were saying that in certain situations, you're not going to find a state that is exactly on the grid of values provided by the tables. And so we're going to use linear interpolation between adjacent entries. And you are going to love linear interpolation, okay? You are just going to absolutely love it. Okay, so let's look at this. Let's now look at table A4. Let's look at superheated water vapor at 10 bar 215 degrees Celsius. And we're going to do linear interpolation. So here we are. We do not have a 215 entry. We have a 200. We have a 240. We're going to have to make that entry for 215 exactly between here. So what are we going to do? We are going to pretend that the data from 200 and to 240 is a straight line between those two, linear. And then we're going to go and put a place 215 and say somewhere along that line 215 is there, and we're going to read off where our specific volume is. Okay, so how are we going to do that? We're going to match slopes. The slope of this big line has to be equal to the slope of this small line. So here we're going to do final minus initial of specific volume over final minus initial temperature. And then we're going to go for the smaller line, and we're going to go with the final, which we don't know, minus the initial, over the final minus the initial, and then we have one unknown that we're going to solve for. This is one way to do this. I could also flip this equation and do temperature over specific volume. Okay? Or I could do initial minus final over initial minus final. It doesn't matter. I encourage you to play around with this. As long as we have these things matched up so that we're subtracting those two, we're going to be fine. We're going to be fine. And this is what we're going to do to find specific volume. Okay? That is going to be a common thing that you're going to have to do this semester, is linearly interpolate. Now, there is an easy linear interpolation that I will try to provide to you often when we're dealing with tests, because if you interpolate a lot of values, it really does take some time. But the easy interpolation to do is if your number is exactly halfway between two table entries. So if you have 200 degrees Celsius and 240, and I gave you 220, because that is exactly halfway between two values, all you need to do is average these two numbers. The average of these two numbers will give you the value that you need. Okay? But it is important that you look at the adjacent entries in the table. Here I've graphed some of the values, and you can see this is a curved line. There's a bunch of straight lines between all the data points, but overall it's a curved line. So if I'm going between two adjacent values in the table, I can consider that linear interpolation is valid. But if I take the values from a little bit further apart, I'm now going off of that, and I'm going to get bad data. So please, when you're interpolating, only take the two adjacent parts in your tables. Okay, now let's look at the two-phase liquid vapor region. So in the two-phase liquid vapor region, here we're going to look at the temperature table. We can find that we have our saturated liquid data, which is going to all correspond to the points that would fit this line here. And I didn't draw that line very well. That should be right exactly on top of here. Those are the locus of all the points. So if I were to add up all these points and I were to graph them, which is one of your, I'll make that an alternative assignment for you to do, I would find out what this curve looks like. And then if I wanted to do on the other side, I could find out all these data points and find out what that curve looks like. So that's very important information as well. Okay. Now note, it's very important to note this. In some of your tables, the specific volume here, for the liquid, it shows you VF times 10 to the third. What it's telling you is that this value is not 1.0001, or here I've got 1.0002. This is 1.002 times 10 to the negative third. And that confuses people. Why? Dr. White, I don't understand that. Because what this means is that in order to put this value in the table, I took the VF value times 10 to the third and put it in the table. So if you want to get it out of the table, you're going to have to divide by 10 to the third to use it in your calculations. And so that's exactly what they're trying to tell you here. Okay? This is a huge point. You will mess up if you just put the numbers in as 1.002. You will mess up if you put it in as 1.002 times 10 to the third. It's important that you know it's 1.002 times 10 to the negative third. Please star that. Make sure that you understand that information. Okay. We talked about the two-phase liquid vapor region. We talked about quality. I showed you these calculations. This is just some slides to show you again how this came up with it. I think that what I did on OneNote is a little bit more descriptive than this slide here is. Okay. And I told you that this is pressure and temperature are not independent because it's two-phase. They can't be used to fix the state. We need to have quality when we're on that saturation line. So that line, that straight line that goes from saturated liquid to saturated vapor, that is called the saturation line. Okay, we need to know when they're on the saturation line. And I also told you that this quality can be used for a specific volume and internal energy. It can also be used for enthalpy, which we haven't talked about yet, but again, it's there. It's not, the equation doesn't change, and that's nice. That's nice that doesn't change. Okay, so let's look at how we would do this, and this is going to be the last thing we're going to talk about, and then I'll let you free. A system consists of a two-phase liquid vapor mixture of water at 6 degrees Celsius at a quality of 0.4. So we know we're at 6 degrees Celsius, a nice even temperature, so we go to our temperature saturation table and go to 6 degrees. Okay, so here it is, here's 6 degrees, and we know that we are trying to find the specific volume, so we know look up the saturated liquid and the saturated vapor. And so what we're going to do is we're going to just use this equation and plug and chug. VF is equal to 1.00, this should be 0.01, you need to fix that, times 10 to the third meters cubed per kilogram, and VG is equal to 137.734 meters cubed per kilogram. And when I put that into my equation and I plop it out here, plop it out, it's going to be, specific volume is 55.094. And that seems to make some sense. If I'm about 40% along the line, I am going to be, a little under 60, so that's 55, makes reasonable sense. Now, if my calculation was like 1, that doesn't seem right. If the calculation is like 1.25, I'm too close to the saturated vapor. I should be somewhere in between there. So that's kind of how this works. That's exactly how this works. You are going to need to figure out how to set the state here, and we will be practicing that as we get going. And I'm not going to go over this problem. I think this is a little bit more than what I want to do for today's lecture. We will talk about this problem in class. I'm assigning you homework for today. Okay, this homework is due on Friday. If you want to get ahead and you want to read the chapter, if you want to look at the documents that I've presented to you online, you sure can, and you can get a hold of things. But I am going to suggest that Wednesday's lecture might be very helpful in helping you get your homework done. I would look at it. I would start writing it out. I'd start getting it ready. But again, you probably need Wednesday's lecture or Wednesday's session, in-person session, to help you solve the homework that's due on Friday. Okay, so I know that some of you get ahead of the game and some of you kind of wait, but I'm going to ask that you wait until Wednesday. Okay. Why don't I sign it on Wednesday? Because I want you to get some practice in and have it due on Friday, so you have something done before the exam that's on the next Monday. So I'm kind of being sneaky here, but again, I want you to do this right. I want you to have some practice on it. And I think if you see my lecture on Wednesday, which all I'm going to do on the video is set the state and find properties, and in person on Wednesday, all I'm going to do is set the state and find properties, then you're going to have enough practice that I think the homework for that night will be pretty straightforward. Okay? All right, we'll end there, and I'll let you go. Have a good and safe weekend. Stay healthy, and we will see you next week.